Hello and welcome in this video, and in today's topic we will discuss about two-dimensional random variables. Okay, so we are going to discuss about two-dimensional random variables, and in particular we will discuss two-dimensional discrete random variables. Okay, so first of all, where we need these two-dimensional random variables. So in some experiments we have to deal with two informations at a time, like in case of electric circuit. Suppose you are dealing with an electric circuit, then we are having two information. One is voltage in the circuit, and the second one, or you can mark this as voltage. So let us consider this X, and the second one is current in the circuit. Okay, so in this way you are having two informations which with which you have to deal with, or the conventional notation for these quantities are V and small I, right? And similarly, if you are dealing with suppose a group of students, so if you are dealing with a group of students, then if you are talking only about their length or weight, then it is a case of single variable. But when you are talking about both simultaneously, means you are talking about height of the students and the weight of the students. So again we have two informations. Let us mark these informations by X and Y respectively. So you can see that there are many other situations where we have to deal with the two information side by side. So this creates a scope for two-dimensional random variables. Okay, so if we have to define that where we have the concept of two-dimensional random variable, so the condition is that we are having two random variables X and Y, and the condition is that they should be defined on the same sample space. Okay, they should be defined on the same sample space. And in this case we are having the concept of two-dimensional random variable, or you can say that we are having two-dimensional, so this is the case of same sample space. Okay, so in this situation we can apply the concept of two-dimensional random variable. So we know that X and Y are said to be discrete if if they are taking either finite number of values or countable number of values. Okay, so now we are having the concept of, so this is just a brief of the situation where we can apply the two-dimensional random variable. Now let us begin with our main discussion. So that is a two-dimensional discrete random variable. Okay, so two-dimensional discrete random variable. So if you are talking about the two-dimensional discrete random variable, so let us assume that we are having two random variables X and Y, and there are different possible values for X, like x1, x2, and up to xn. And similarly we are having the different values for y1, y2 up to yn. So here I would like to mention that it is not necessary that m is equals to n, or m may not be equals to n. So both situations are very much possible, that you may have equal number of values of both the variables, or you may have an equal number of values of both the variables. Now once we are having these values, Now we are having the probabilities here for a pair. Means you can define the probability of for a pair like x will take the value x1 and y will take the value y1. So the probability for the same is you can define as p11. So this is just notation. Similarly, when p is the probability for the case when x is taking the value x1 and y is taking the value y2. So the probability for the same is p12. Okay. So in this way you can define these probabilities, and keeping this in mind, basically we can represent this situation in tabular form, like this table. So you are having this table here, and in this table we are having the variables. So here in this table we are having the values and their probabilities. Okay, so we are having the values and their probabilities. So this is a table. This is just for illustration purpose, so that you can have an understanding how we can so let us take the values. So here if we are writing x over here, so it means that we are taking the values of x on this row, that is the top row of this table. So let us consider this as x1, then x2, and we are having x3 and so on, and at last we are having the value xn. And similarly we are having here the values of y1, y2 and so on and up to ym. So we are having this table. Now in these cells we are having this probabilities, means x is taking the value x1 and y is taking the value y1. So the probability of the same is p11. Similarly x is taking the value x2 and y is still at y1. So the probability for the same is p12 and so on, and at last we are having here p1n. And similarly we are having p21, p22 up to p2n. So this is simple representation, and here we are having pm1, pm2 and up to pmn. So this is how we can obtain the probability distribution of these two-dimensional discrete random variable. So this is one possibility, and another possibility as that you are having the probability mass function. So probability mass function is simply represented or you can write it this in short as PMF. So this is a function which is defined in terms of x and y, and it may have any expression like one possible way is k times x plus y square, and here you are provided with the information that the possible values of x, let's say up to or you can define these values up to 4. So let's say x is taking 4 values, and similarly we are having the values of y. So y is taking the value as, let's say, 0, 1 and 2. So y is taking 3 values here and x is taking 4 values. So now you can convert this information into this tabular form. So how can we do that? So let us discuss this. So what you will do first, in this situation you will write this table, and first of all you just need to put the values here, and again it is not mandatory that you are writing the values of x on the top row and y on column. You may write x over the first row, means the top row of this table, or on this first column. So I am considering here again x here and y here. So we are having 4 values of x. So this is 1, 2, 3 and the last value is 4. Similarly, we are having the values of y, which we are writing on this first column. So this is 0, 1 and 2. Now what we have to do, in order to complete this table, we should have the information, or we should have the values in each of these cells. So when you are here, so you can see that our for this particular cell, our value of x is for this particular cell, the value of x is 1 and the value of y is 0. So what you will do, you will put the values of x here and y here. So when you put x is equals to 1, okay, so I am writing here. So for the first cell, for this particular cell, we are having, you can write, for x is equals to 1 and y is equals to 0 for this particular cell, you can see. And you can obtain the probability, okay, the probability that x is 1 and y is 0 using this function. Okay, so you are having k times 1 plus 0, because the square of 0 is 0, so this is coming out as k. So here we are having k. Similarly, for next we can obtain the probability for x is equals to 2, y is equals to 0 is k times 2 plus 0, so this is 2k. So here we are having 2k. Similarly, you can obtain here 3k, then 4k, because for this particular row the value of y is 0. And now another thing is, for this second row, you can see that the value of y is 1. So again we start with the y is equals to 1, and when you are in this first cell here, so the value of x is 1 and y is 1. So when you put here x is equals to 1, y is equals to 1, so this is coming out 2k. Okay. And similarly here you are having, when you put x is equals to 2 and y is equals to 1, so you will get 3k, and we are having 4k, and finally we are having 5k. And the next or the last row of this table, for this last row we are having the value of y is 2, and so for the first cell the value of x is 1 and y is 2. So when you put these two values here, you will obtain the value or the entry for this cell as 5k. Now the next is 6k. Now the next is when you put y is equals to 2 and x is equals to 3, so this is coming out 7k, and here you are having 8k, right? So you can have either this table, or you may have this function along with the possible values of the random variables x and y. So you can make this table, right? Now what we will get, now we will discuss about the properties of this table, which is the probability distribution here. So we are having certain properties. Okay, so the properties are two main properties we are having here. So the first thing is Pij is always greater than equals to 0 for all I comma j, because means this property states that you will not have any negative entry in this any of these cells. Okay, because it is obvious, because Pij is representing the probability, and we know that the range for the probability is 0 to 1, so it cannot be negative. The second property, which is very useful, is that when you are adding all the entries of this table, okay, So when you are adding all the entries, so the sum of all the entries should be 1. So this is how we can obtain the values of the unknowns. We will use this property like in this table in order to get the value of any unknown involved in the table. So we can make use of this property here. Okay, so this is these two are very important properties, and we should keep in mind especially the second one. Okay, this is very helpful in order to solve certain problems, right? So in order to illustrate the use of these properties, let us suppose here we have to find the value of k. Okay, we have to find out the value of k. What should be the value of k? So as this second property states that when you are adding all the probabilities you will get 1. So we are using the same thing, that we are using this property that when you are performing this summation, so this should be 1. So using this, now you can see that here we are having k plus 2k plus 3k plus 4k. These are the entries in the first row. Now these are the entries in the first row. Now when you are considering the second row, so these are 2k plus 3k plus 4k 5k, and similarly in the last row, means the third row, we are having 5k 6k 7k plus 8k, and this sum should be 1. So when you add all these entries, so adding one by one, so here you can see that the sum of the first bracket is 10k, plus here you can see that it is 14k, and lastly we are having 26k, which is 1. So this implies that this sum is 1. Now when you add all these values here, so you will get 50k is equals to 1, and this finally provides you the value of the unknown, which is coming out as 1 by 50. Okay, so this is how we can find out the value of any unknown involved in the table or in the probability mass function. Okay, so this is how this is a very basic problem, and we should make use of this property in order to solve such problems. Okay, now another important thing is when you are dealing with the two-dimensional random variables, so this type of table is provides you the joint probability. Joint probability means this is the probability for a pair like this. Okay, you are having the probability of a pair that x is 1, y is 0. In if you are using the notation, then this should be the probability that x is equals to 1, y is equals to 0. So this is the probability of a pair. Now you may get the probability for a single value of any of the variable, and that is known as the marginal. Okay, so marginal probability distribution, or you can simply say the marginal probability. So what we have to do in order to get the marginal probability, so we can again use this or we can take some new problem here. Let us consider that we are given certain problem. Let's say we are having this table with us. So we are having this table, and in this table we are provided with the values of x and y. So this is a very simple example. So here we are having y, here x, and the values of y are 1, 2 and 3, and the values for x are same 1, 2 and 3. And the probabilities are 1 by 12, 1 by 6, 1 by 12, 1 by 6, 1 by 4, 1 by 12, and in the last row we are having 1 by 12, 1 by 12 and 0. And suppose you are looking for the probability for x is equals to 2. Okay. So now, because if you look at this table, so you are not getting the probability for x is equals to 2. Why? Because here you can see that x is equals to 2 is this. Okay. And whenever you are considering this 2, so the probabilities for this value is corresponding to y is equals to 1. Okay. Corresponding to y is equals to 2 and corresponding to y is equals to 3. So the marginal probability is simply defined as the summation of all the probabilities corresponding to that particular value of a random variable. So for x is equals to 2, we are having 1 by 6, which is the probability of x is equals to 2 with y is equals to 1, plus the next probability corresponding to this x is equals to 2 is 1 by 4, and the last probability corresponding to this is 1 by 12. So when you add all these probabilities, so this is simply coming out 6 by 12, or you can say 1 by 2. Okay. So this is simply 1 by 2. So let us note down these probability here. So we may extend this table, and in this extended rows and columns, what we will do, we will write the marginal, okay, marginal probabilities for different values of these two random variables, right? So we will note down these values here. Okay. So you are having, we just calculated the value correspond, the marginal probability corresponding to y is equals to 2, which is coming out 1 by 2. Similarly, if you have to calculate the probability or the marginal probability for x is equals to 1, so again you can see that for corresponding to x is equals to 1, we are having these three probabilities. So again we will adding these probabilities. So this is coming out 4 by 12, or simply you can see that it is coming out 1 by 3. So we just note down here, this is 1 by 3. Lastly, we are having the probability for the last value of this x, which is 3. So again we are having three values, or three values of the probability corresponding to this, which are 1 by 12, 1 by 12 plus 0. So when you are adding this, this is coming out 1 by 6. So this is how we can obtain the marginal probability corresponding to x. Now on the same line, we will obtain the marginal probability for y is equals to 1, 2 and 3. Means the marginal probability for y, means for different values of y. So when you are calculating the probability corresponding to y is equals to 1, so here we are having three probabilities. Now if you are looking at this table, so for y is equals to 1, it will be good if I use different color here. So for y is equals to 1, you can see that now you have to look along the column, because the values or the values of the probability corresponding to different values of y is given in the column. So we are having 1 by 12 plus 1 by 6, which is the next value, plus 1 by 12. So this is coming out 4 by 12, or you can say 1 by 3. Now on the same line, we are having the probability for y is equals to 2. So this is the y is equals to 2, and you can see that again we are having three values. or 3 probabilities corresponding to this y is equals to 2. So this is y upon 6 plus y upon 4 plus y upon 12. So when you add all these values, so you can check that this is coming out simply 6 by 12, or you can say 1 by 2. So again we mentioned these probabilities here. So 1 by 3, 1 by 2, and lastly for y is equals to 3, we are having 1 by 12 plus 1 by 12 plus 0, which is 1 by 6. So we will write here 1 by 6. So this is how we can obtain the marginal probabilities for different values of y. Now sometimes it is asked that you have to find the marginal distribution. Okay, sometimes we have to find the marginal distribution for the random variable. So marginal distribution means we have to find a table. For example, marginal distribution, if we are talking about marginal distribution, so let us first take this for x. So we have to make a table here which is very much similar to the one-dimensional discrete random variable, where in the first row we are having the values of the random variable, and in the next row we are having the probabilities. So when you look at the values, so values are 3 in this particular problem, and the values are 1, 2 and 3. Now in the second row, in place of the probability, we have to mention the marginal probabilities. Okay, so marginal probabilities are 1 by 2, 1 by 3 and 1 by 6. So this is how we can obtain the marginal distribution for x, and similarly, because we have already calculated the marginal probabilities for y, so we are having the marginal probability distribution for y. So again we are having a table which is again similar to the one-dimensional case, and the values of the variable y is same as that of the variable x, and they are 1, 2 and 3, and the probabilities are 1 by 3, 1 by 2 and 1 by 6. So this is how we can obtain the marginal distribution for the random variables x and y. Now here one thing which I would like to mention, that, or you can say that we can make a remark over here, and that remark is, so remark which you can also use as the check condition, that sum of marginals, or you can say the marginal probabilities corresponding to a random variable x or y, out of this any of these random variable is 1. Means whenever you have calculated the marginals, so you can check the correctness of these marginals by adding this. So for example, if you are adding here, if you are adding the marginal probabilities for x, okay, so we are having 1 by 2 plus 1 by 3 plus 1 by 6. Sorry, this is 1 by 6. So this should be coming out as 6 upon 6, which is 1. And on the same line you can check the same situation is here for the second random variable y. So when again you can see that the values are same. Okay, so this is again coming out 6 over 6 and this is 1. So this is how we can obtain the marginal, and we can check that we have obtained the correct values of the marginals. By adding all the values, we should have the value of this sum should be 1. Now next we are taking another problem which is based on the same table. Let's say we have to find the probability that x should be less than 1.5. So this is we have to find that the probability that x is less than equals to 1.5. Now how do we obtain these probabilities? So what we will do, we just move towards the original table, and so here you can see that we are having three values of x which are 1, 2 and 3, and we have to select only those values which satisfies this condition. So this because we know that x has three values 1, 2 and 3. Out of these, only the first value, which is 1, is satisfying this restriction. So we are having this as probability of x is equals to 1, and this will give you you can see that we have already obtained the value of so this is whenever we are having this type of probability. So this is the case of marginal, because you are looking for the probability for a single value of 1, which is the case of marginal, and you can see that here the probability for x is equals to 1 is 1 by 2, right? Now suppose we are having another possibility that we are looking for this type of probability, right? So again you look at the values of x. Here you can see that now we are, due to this this equality here, we can take two values here, which is which are x is equals to 1 and x is equals to 2. And again you can see that we are looking for the probability of a single value, and for x is equals to 1 the probability is 1 by 2, and for x is equals to 2 is the probability is 1 by 3. So this is coming out as 1 by 5 by 6. So this is coming out 5 by 6. So this is how we can calculate the probability. We can also take another part, like let's say we are having or we are looking for the probability that x y is even. Okay, so we know that we are having three values of x. So again just note down the values here so that you have a clear understanding. So we are having three values of x which are 1, 2 and 3, and we are having the same values for y, and the values of y are 1, 2 and 3. So out of these values we have to consider only those values whose product is even. Okay, so xy is even means if you are considering x is equals to 1, so 1 and the first value of y is 1, so 1 into 1 is not an even number, but 1 into 2 is an even number. So we are looking for this, and this is the we have to consider all those pairs which are satisfying this condition. Okay, means the entries of x and y whose product is an even number. So we have to consider all those possible values. So the first is x is equals to 1 and we have y is equals to 2. Now if you are continue with the x is equals to 1, then the next value is 3, and we know that 1 into 3 is not an even number. So for x is equals to 1 only we are having y is equals to 2, so that the product of 1 and 2 is coming out as even. Now next, if you change the next number, or so x is equals to 2, now we know that any product of or any multiple of 2 is an even number. So for x is equals to 2, you can say that if you are considering y is equals to 1, so 2 into 1 is 2, which is an even number. Similarly, you are having x is equals to 2 and y is equals to 2, so the product is again 4, which is again an even number. Lastly, for this x is equals to 2, we can take y is equals to 3, and the product you can check that it is 6. X is equals to 2 and y is equals to 3, so the product of 2 and 3 is 6. So this is an even number. Now we have completed all the possibilities for this x is equals to 2, so we have to move towards this x is equals to 3. So when you are having x is equals to 3, and if you are taking y is equals to 1, so 3 into 1 is 3, which is not an even number, so we cannot take this value, means we cannot take y is equals to 1 with x is equals to 3. Now next we can take y is equals to 2, which so you can see that clearly 3 into 2 is 6, which is an even number. And lastly, you cannot take this y is equals to 3 with x is equals to 3, because the product of 3 and 3 is 9, which is not an even number. So we have to consider all those pairs here which are satisfying the given condition, and the condition is that the product of these two the product of the values of these two random variables should be an even number. So we have filtered out those values, and what we have to do next, we have to add all these probabilities. Okay, and these probabilities are available in our table, means you can check that for x is equals to 2 and y is equals to 1, the probability is 1 by 6. X is equals to 2, y is equals to 2, the probability is 1 by 4. Similarly, x is equals to 2, y is equals to 3. So we are having all such probabilities in this table. So we are putting these values here. So the values are 1 by 6, 1 by 6 plus 1 by 4 plus 1 by 12 plus 1 by 12. So this is coming out as 9 by 12, or you can say that it is 3 by 4. So this is how we can obtain the probabilities for a certain given condition. Okay. Now we can next discuss about the conditional probabilities. Okay. So conditional probability of one of the random variable given certain value of the other. Okay. So conditional probability. So this is let's say we have to find the probability corresponding to some given value of x, and we are provided that value of y is yj. So this is the situation of probability for x is equals to xi given y is equals to yj, which is the case of conditional probability. Okay, so this is the situation of conditional probability. So whenever we are having this situation, this probability can be obtained as probability of x is equals to xi, y is equals to yj divided by the probability of y is equals to yj. So this is the joint probability. Okay, this is the joint probability of x is equals to xi and y is equals to yj, and this is the marginal. Okay, marginal of y is equals to yj. So you can see that we have to find out the marginal, because originally we are provided with the joint probability. So in order to obtain this conditional probability, all we need is the marginal corresponding to y is equals to yj. And similarly you can have the conditional probability for some given value of y and given value of x. So you may have the situation that you are looking for the conditional probability of y is equals to yj given x is equals to xi. So this should be probability of y is equals to yj, x is equals to xi divided by probability of y is equals to yj. Sorry, this time we are having the probability that x is equals to xi, because this is the given condition. Okay, so we are looking for this. So again you can see that this is our joint probability. Okay, and in the denominator we are having the marginal of x is equals to xi. This is how we can find out the conditional probability. So again, if we can take a problem over on this. So let's say we are having a distribution or the probability distribution which is given here, and the situation is okay, so let us consider the problem on this. Means how do we calculate the conditional probability? Okay, so let us consider the case of two-dimensional discrete random variable where we are having this. Let's say we are having this joint PMF. Okay, so we are given the joint PMF of xy as is given as probability of the pair is k times 2x plus 3y, and we are having this value of x and y. So the values of x are 0, 1, 2, and the values of y are 1, 2, and 3. So we have to find the conditional probabilities, or you can say the conditional distribution of x. Now whenever we are looking for the conditional distribution, so we are having some fixed value of the second variable, let's say y is equals to 2. So first of all we have to make the table, or you can say the joint probability distribution of these two random variables. So this is we know that it is a table, and in this table we are having the values of x and y and their joint probabilities. So we are having x and y, and the probability the values of x are here. So we are given 0, 1, 2, and the values of y are given on the first column. So the values are 1, 2, and 3. And when you are putting these values, means when you just like our first example, if you are here, so for this particular position the value of x is 0 and the value of y is 1. So when you put x is equals to 0 and y is equals to 1 here, so you will obtain this as 3k. Okay, and similarly you will obtain here y 5k, because here you can see that x is equals to 1 and y is equals to 1. And next we are having 7k, then we are having 6k, 8k, 10k, 9k, 11k, and lastly we are having 13k. So our primary step is to find out the values of k. So how do we do that? We just need to add all these values, and here we are again making use of the property that sum of all the probabilities should be 1. So using this, we are using this property, and when you are using this property, so we are having 3k plus 5k plus 7k. These are the values in the first row, and next we are having 6k plus 8k plus 10k plus 9k plus 11k plus 13k. So we are having total 9 values, and we have to add all these 9 values, and we should make this sum equal to 1. So finally we are having 72k as 1, and this will give you the value of k as 1 over 72. So this is our first step. Whenever we are having any unknown involved in our distribution table, so we have to find first of all the value of that unknown, right? Now our problem is we have to find the conditional distribution of x given y is equals to 2. So what does it mean? It simply means that we have to find the values or the probabilities corresponding to the different values of x, but we have to fix our y at 2. So this is the case of conditional probability. So now as we discussed in the beginning, that just before this problem, that this is how we can obtain the conditional probability. So here we have required two things. First is the joint probability. So joint probability is given here, and the second is the conditional marginal. Now the marginal for y is equals to 2, okay, because we know that this should be probability of x is equals to xi, y is equals to 2 divided by the probability for y is equals to 2. Now this is the marginal. So next, in order to calculate the conditional probabilities for x, we have to find the marginal for y is equals to 2. Okay, so the marginal probability or marginal probability of y is equals to 2 is, now you can see that this y is equals to 2 is given here, and the probabilities corresponding to this are 6k plus 8k plus 10k. So this is coming out as 24k, and if you are putting the value of k, so this should be 24 over 72. Now we will change the value of xi one by one. So we know that x is taking three values, 0, 1 and 2. So the conditional probability for the first value of x, which is for x is equals to 0. So this is the situation that x is equals to 0 given y is equals to 2, and the probability for the same is probability of x is equals to 0, y is equals to 2 divided by the marginal probability of y is equals to 2. Now this is the joint probability, and this joint probability is given here. So x is equals to 0 and y is equals to 2. You can see that this is the probability for this pair is 6k, and if you are putting the value of k, which is 1 by 72, so this is 6 upon 72, and you are having 24 over 72, which is the value of the marginal, and on solving you will obtain this as 1 by 4. Now next value is x is equals to 1, and the conditional probability for x is equals to 1 given y is equals to 2 is given as probability of x is equals to 1, y is equals to 2 divided by probability of y is equals to 2. Okay, so here you can see that for x is equals to 1 and y is equals to 2, so the probability for the same is 8k, and we have to divide this by 24k, which is given here. Okay, Here, because an unknown is involved here, so you can cancel out the value of the unknown. Otherwise you can put the value and after that you can cancel out. So this is coming out as 8 over 24, which is 1 by 3. And lastly we are having for x is equals to, the last value of x is 2. So the probability of x is equals to 2 given y is equals to 2 is, simply you can see that this should be probability of x is equals to 2, y is equals to 2 divided by probability of y is equals to 2. So again in the numerator we are having the joint probability, which is given as 10k divided by the marginal for y is equals to 2, which is 24k, and this is coming out as 10 by 24, or you can say 5 by 12. So if you want the tabular representation of this conditional distribution, so again we are having a table, and in this table in the first row we are again having the values of x, which are 0, 1 and 2, and in the second row we are having here the conditional probabilities for x is equals to xi given y is equals to 2, and we have already calculated these probabilities. So for x is equals to 0, the conditional probability, you can see that it is 1 by 4 here, this is 1 by 4. So the first entry in this row is 1 by 4, the second entry is 1 by 3, and the last entry is 5 by 12. So this is the conditional distribution for x given y is equals to 2. Okay, so this is how we can have the concept of two-dimensional discrete random variable, and we can calculate different types of probabilities once we are provided with the mass function or the joint distribution of the random variables. Okay, so in this video we have discussed about all these things. In the next video we will come up with more problems on the two-dimensional discrete random variables, such that we can calculate the different types of probabilities and some more problems. So that's all in this for this video. Thank you.